Okay, taking a look at transformations. The formula we're going to know and love is g of x equals a f quantity b quantity x minus h plus k. Each of the letters in color, a, b, h, and k, do something different to the graph. So we'll start by taking a look at the a. So for starters, when we're looking at that number in the very front, the a value, if a is negative, then we're going to say that the graph is reflected over the x-axis, or we could say reflected vertically. That takes care of the negative aspect. So if we just look at the absolute value of a now, if it's bigger than 1, we say that it's stretched vertically. Whereas if it's less than 1, we say that it's compressed vertically. Taking a look at the b value now, the one in green, notice b is always located right between f and x, and there has to be a parenthesis between b and the x value, or it's not considered to be in graphing form. Once it is in graphing form, if b is negative, then we'd say that the graph reflected over the y-axis, or you could say it reflected horizontally. So that takes care of if b is negative. So now just looking at the absolute value of b, if b is a number bigger than 1, then it actually compresses the graph horizontally. So if you look at the equation, b is in parentheses, and it's also with the x value. Everything in those parentheses with the x value does the opposite of what you would think it does. So if b is a big number, it actually compresses the graph horizontally. Whereas if the absolute value b is less than 1, if it's a decimal like 0.2 or a fraction like 1/4, then it actually stretches the graph horizontally. Along those same lines about the x being in parentheses and everything being opposite of what you think, if the equation is f of x minus h, it actually moves the graph h units to the right, even though it says minus. Whereas if it's x plus h, then it moves the graph h units to the left. K is on the outside of the parentheses, so k is true to form. So if k is positive, it'll move up k. And if it's minus k, it'll move down k units. So this is an overview of what all the different variables would do to your transformation. So on the next page, we're going to start putting it into practice and seeing what to do with the points in order to get our transformation. So here is our main really important formula. There's that transformation equation at the top again. And then you'll notice that to get the new xy's, you take your original x, you divide it by b. So the equation says b times x, and we divide it by b, and then we add h. So again, notice the equation says x minus h, but we add it. So the x values are the ones that are a little more difficult, and it's opposite whatever's happening in the equation. To get the new y values, you simply take your y, you do a times y plus k, which is what the original equation says, a times y plus k. So I'll make up a graph that we can use and we can start doing a practice problem. Okay, so here's our first transformation problem we're going to complete. You'll notice the graph is given on the the right, and on the left-hand side is the point values from that same graph. So those are our original graph that we're going to transform. First thing you need to notice is that our g of x is not in graphing form. It is not okay to have the b value touching x like this. So we're going to need to factor it out. So take a minute and see if you can rewrite this equation in graphing form. So factoring out the 3, because we always need our parentheses to start with a single positive x, so we factored out the 3. When you divide by 3, you get x, like you're supposed to, and then when you divide negative 3 by 3, you get negative 1. So it's always a good idea to look back at your equation and see if I distributed that 3, I would get 3x, that's good. If I distributed that 3 here, I would get negative 3, so that's good. So now we're in graphing form. So another thing you might want to do is start identifying a, b, h, and k. So if you line it up with the original equation at the top, a is going to be the negative 2, b is going to be that 3 value that we factored out. After factoring that out, we can see that h is in here, 1, and that the k is the one at the very end. So now we'll just put it into the formula. Formula says to get our new x values, so as a point, we take x and we divide it by b. So we are going to do x over 3. And then we do opposite of what the parentheses says. It says -1, so then we're going to add 1. For the y values, we do exactly what the equation says, -2y plus 1. So starting with the x's, this sometimes is a good time for mixed numbers. I am going to do the x value, -2 over 3, and then the equation says plus 1. -2/3 plus 1 just gives me 1/3. This is not a comma, this is my work, so let's make equals. Next line, just the x's. -1 divided by 3 plus 1. Doing the math will give me 2/3. 1 divided by 3 plus 1, and this is where mixed numbers are. So to get our x values, we're going to do what the formula says. X divided by b. Our b value is the 3 right here. So x divided by 3 would give me just x over 3. And then our h right now says -1, but remember it's in parentheses, so we do the opposite, so plus 1, comma. The a value is -2, so -2y. And the k value is the plus 1 at the end, so plus 1. So we go through each x value, we divide it by 3 and add 1. So -2 over 3 plus 1. -1 over 3 plus 1. 1 over 3 plus 1. 3 over 3 plus 1. Now let's go through and actually do the math. So -2/3 plus 1 would give me 1/3. -1/3 plus 1 would give me 2/3. 1/3 plus 1 would give me 1 and 1/3. Sometimes mixed numbers are more useful. And 1 plus 1 would give me 2. So those are my x values. Hopefully the y values would be easier to do just in your head because there are no fractions involved. So this is where I'll start my points. Those are the x values. Now I'm going to take every y, multiply it by -2 and add 1. 2 times -2 is -4, plus 1 is -3. -1 times -2 is 2, plus 1 is 3. 1 times -2 is -2, plus 1 is -1, and the same thing for the last answer. So these are the new points. Plot those new points and see if you can graph the new transformation. So it's a little hard to be perfect because we do have such small x values. We're dealing with fractions and we have to estimate, but here's the graph I got. And then believe it or not, one of the biggest points on your test is being able to describe the transformation. So let's try to color code it so we can look back and see what happened. First of all, the 2 is negative, so that means that it's reflected over the x-axis. Then that same red 2, it's a 2, which is a number bigger than 1, forgetting that it's negative. It's bigger than 1, so it's stretched vertically. You have to say over the x-axis, and you have to say stretched vertically, because there's other options depending on the values. Then if I'm looking for other numbers in the equation, there's that 3 that was underlined in green. The fact that it's a 3, first of all, it's positive, so there's no reflect. But that 3 is bigger than 1, but it's in parentheses with the x, so that's actually compressed. And it's horizontally. Then we have the blue -1, but remember it's in parentheses, so that actually made it move right 1. And then the orange +1 at the end made it move up 1. This was our first transformation example. Okay, for these next practice problems, I'm going to assume that you can make a table and do the algebra on your own time. What we really need to practice is the new stuff. So here's a transformation. It's currently not in graphing form. So your first step should be to factor out that -1/3. It's not allowed to be touching the x like that. And when you factor it out, it's going to change that +1. See if you can get this into graphing form. So far I've done the setup. This is what graphing form will always look like. F brackets, if there's a b value, it goes in the space that I've left, and then your parentheses x needs to be a single positive x value. So hopefully it's obvious that we need to factor out -1/3 in order for it to look like this. The tricky part is what goes in the gap. And this is when sometimes it's easier to go backwards. I would be distributing -1/3 here, and I'd get -1/3 x. I would be distributing -1/3 here, and I need to get +1. So -1/3 times what would give me +1? -3 is what you end up with in that gap. So now see if you can figure out what you would do algebraically to your original xy's in order to get your new xy's. So remember, anything that was in the parentheses always end up made opposite. So what I'm trying to say is, in the parentheses right now, it's x times -1/3. So we would do the opposite of that. We would do x divided by -1/3. But when you divide by a fraction, you just flip and multiply. So you get -3 times x. Also in the parentheses right now is a -3, so we would do the opposite, +3, comma. Then for the y values, 1/2 y -4, just like the equation says. So again, you can practice doing the algebra, taking x, multiplying it by -3, and adding 3 later. But now I want to work on naming the transformations. Here's a hint. In this equation, there are 5 transformations that happened. See if you can name all 5 transformations. So here they all are. I like to go from left to right. The first thing I see is a 1/2. 1/2 is smaller than 1. It compresses vertically. Then I see a negative in front of that 1/3. It's in the parentheses with x, and it's negative, so it reflects over the y-axis. Then the fact that it's 1/3, which is a small number, but it's in parentheses with x, so it does the opposite of what you would think. It stretches it horizontally. Then the -3 moves it right 3, and the -4 moves it down 4. Okay, I think this will be our last example. There's our new g of x. Take a minute, press pause, see if you can get it in graphing form, because it's not okay to start a parentheses with a -x. So here it is in graphing form. Notice I factored the -1 out, and when I did that, x became positive and the 4 became negative. So now that it's in graphing form, see if you can figure out the formula to get your new xy. Here's the math I would do to get my new xy. -x plus 4, -3y plus 2. Finally, see if you can figure out the transformations. I'll give you a hint on this one. There happens to be 5 also. And here they are. Negative in the very front, reflect over x-axis. 3, stretch vertically. Negative in the middle, reflect over y-axis. -4, right 4, plus 2, up